Moments mean that was the turning effect of the force. And when I told you that when we talk about the turning effect, there are so many important points to be considered in that topic. First of all, you must know that you must know the definition of the moment, and that is actually the product of force and moment arm. And moment, mathematically, moment is equals to F into D. Mathematically, it is equals to F times D, and its unit is Newton meter. And there are so many examples in our daily life in which we see the moment. For example, when a person is just working with a spanner, a person is opening the bottle car door, and so on, right? Wheelbarrow, working with the steering wheel, and etc. So all of that was basically the examples of the moment. Then I went back to the moment arm. When I was explaining moment arm, that then I told you that moment arm is actually the perpendicular distance, only perpendicular distance from pivot to the line of force. So, for example, here is a body, that is the pivot. Pivot is that point or that line about which the body rotates. So here a person is applying some force, right? And that force is applied at certain, along with the line. This red line is the line of force, right? I have mentioned that this is the line of force, this one. And that force is making certain angles with black line and green line. So black line is not making a 90-degree angle. It is not used as D. You will not use it as D, I mean as a moment arm. But this green line is perpendicular. It is making an angle 90-degree with the line of force. That's why I will use that for my further calculations of the moment. So very, very important point what I have discussed with you people, that whenever you are calculating the moment, don't forget to say that the distance, if the distance is not perpendicular, then that force or that distance will not used in the moment. Okay, then it is a vector quantity, I told you. And definitely we have to know about that. If it is vector, then definitely it will have a direction, and there are two directions of the pivot, sorry, of the moment. One of them is clockwise and the second one is anti-clockwise. Yes, we people were here. Okay, you asked me so many questions that day. I told you that if a spanner is let's say 1.0.12 meter and 90 Newton force is applied to open a nut, then moment will be 18 Newton meter. Just multiplied these two values, and by the same nut, if the same nut is going to be opened with the help of a long spanner which is 2 meter long, I have to apply very small force, and that force is to be calculated in this question, in this one. Here 18 Newton meter is basically the moment required, and 18 is equals to force into distance, a perpendicular moment or perpendicular distance. So that distance is now 2 meter. That force is equals to moment divided by distance, and moment is 18 and distance is, so just 9 Newton force is required. That is why by using a long spanner or long distance, a minimum force is required to produce the moment. And this is what, this is asked in your frequent questions in your exams, that if you are using a long spanner, you will have to apply small force to create the same moment. And Mariam, you asked me a question that why don't we put the door, the hinges on the the handle near the hinges. So I told you that these are the hinges, right? And these are actually the axis of rotation. Okay, these are what, these are axis of rotation. So the door rotates about these hinges. If you see from the top, door rotates about these. So that is why when you apply a force perpendicular to that one, force is applied in this direction. Okay, that force will cause the door to be open easily. In the same way, I told you that if you are going to put the handle in the center of the door or in the middle of the door, then you will, the door will open or lock when you will provide the same moment. For example, here I just given you that if door requires 200 Newton meter moment, then the force will be required for 100 newton if the door handle is 2 meter away from the hinges. But if it is 1 meter away from the hinges, then 200 newton force will be required, which is very big force, is it? So those doors which are having small distances, perpendicular distances, there we have to apply more force. Is then right after that we are going to talk about the equilibrium today, inshallah. I'm starting right from here, so I hope that it will be very clear to you. That is equilibrium. So equilibrium is actually that when you when your body is in under the influence of some forces, and those forces are balanced, right? Forces are balanced. When the body is considered to be in equilibrium, if the body has no rotation and no acceleration, simply, I'm just writing two words: if a body has no rotation and no acceleration, right? Then it is in equilibrium. These two are actually different conditions of the equilibrium. Here I'm going to tell you about rotation. If a body in equilibrium experiences no acceleration, and it will remain in equilibrium until unless it is disturbed by an external force. I mean to say, if net force is equals to zero, if F net equals to zero, then what will happen? The body would have an acceleration. Then acceleration will be zero. So body moves with constant speed. So there are two conditions: either body is at rest or it moves with constant speed. So if the body moves with constant speed, if constant speed is there, acceleration will always be zero. If a body is in equilibrium, there are two conditions. Condition number one, that sum of all the forces must be equal to zero. Okay, sum of all the forces acting on the body must be equal to zero. Everything which is either at rest, okay, either at rest or moves with uniform velocity. Just use this word, it will be more suitable. Uniform velocity without rotation. Without rotation. If you have this condition for a body, then surely the body is in equilibrium. Okay? A body is at rest. Are you getting it? A body is at rest, or it moves with uniform velocity. It means it is not having any change, or you can say constant velocity. So there are two conditions for equilibrium. Condition number one, right? These are asked in your exam for 2 marks. Condition number one, right? How many conditions are there? There is two conditions. Condition one is, what is condition number one? That the body will be in equilibrium if sum of all forces equals to zero. If sum of all forces equals to zero. Let's say I'm going to draw a diagram. If this is a box and Ariba is applying a force on this box, 100 Newton towards right, Zainab is applying a force of 70 Newton towards left, and Mariam supports Zainab by applying a 30 Newton force towards left. So what about this block? It will
Stationary.
remain in equilibrium. Okay, then what about its weight force? Who is going to balance the weight force? No one, na? Because you
Gravity.
people are just producing the equilibrium along x-axis. Along y-axis, it was not in equilibrium. To keep that in equilibrium, I just put that box on the table, and now the table is supporting it in the upward direction. That is why the normal reaction force of the table and weight are equal. It will not rotate anywhere. But if Khadija enters and she applies a force here, let's say that force is 40 Newton. Now this block is in equilibrium. Now there is a resultant force. Are you getting my point?
Yes, sir.
Sure na? ऐसे वाला yes sir नहीं वाला confirm yes sir.
So, sir, now it's
Yeah.
not in equilibrium.
Sorry, Zainab, what are you saying?
So now it's not in equilibrium.
Yeah,
114.
now it is not in equilibrium. When Khadija entered, actually, she applied a force which is not being balanced by any other direction. Here in this situation, oh, here in this situation, the block is balanced, right? Do you see this? But in condition number two, I'm going to draw a new domain of forces. Its weight was downward. It was 90 Newton. Normal reaction force was 90 Newton. Support of the table. The rightward force of Ariba was 100 Newton. Khadija and Mariam combinedly it was 70 plus 30, 100 Newton. And everything is balanced. Everything was settled down. But Khadija entered and she applied a force of 40 Newton. Now there is no any force to balance that. Is it? So it is not any. The next is the second condition. Second condition is that sum of all the moments should be equal. Second condition. Second condition of equilibrium is basically that if a body is in equilibrium, then there must not be any rotation. No rotation must be there. Okay. If there is no rotation, the body is also called an equilibrium. Like if there is a block and let's say there is a screwdriver, sorry, there is a screw or there is a turntable, and that turntable is under the circumstances of balanced forces. There the people are applying the force in such a way that the forces are balanced. See, the forces are balanced. I'm going to try to draw the forces through it. Okay, so these are the forces. Suppose it is 100 Newton force.
Huh?
It is 100 Newton force here. It is 100 Newton force here. So it is in equilibrium. But if it is rotating by any reason, or by any source, or by any cause, then it is not in equilibrium. For example, you are rotating the steering wheel of your car. It is at rest, but rotating. So I want to say that the steering wheel of the car, which you are rotating, that is not in equilibrium because it is at rest. Yes, we believe that it is at rest, but it rotates. Okay, it rotates in several directions. That is why if it rotates like this, it means that body, or that has some rotation in it. So please remember one thing, that when a body has rotation, then it will have no equilibrium at all. Rotation yes, equilibrium no. They cannot be at the same. For this purpose, I will let you now another important topic of the moments, that is sum of, this is the second condition, that sum of clockwise movements must be equal to sum of anti-clockwise movements, right? As I told you that movement is, this is second condition. Here I am going to write second condition. As I told you that moments are of two types. Is it clockwise and anti-clockwise? So for example, there is a body, and that body has some moments applied on it. This is the pivot. Let's say this is the pivot. As I told you that this is the pivot, and you are going to apply some force in this direction. This is the force which will cause the body to rotate in this direction. And this is, sorry, let me draw the forces in other way around. This is the force which is causing this body to rotate in this direction, is it? And if I draw another force here, that force will be basically causing this body to rotate in this direction. So this is your F1, and the distance from this point to this point, that is your D1. And this force, purple one, is your F2, and that distance is your D2. So uh, Where, which one is the clockwise movement? This F1 is your clockwise movement. So that is your clockwise movement. Why? Because body is rotated at clockwise, right? So clockwise and anti-clockwise movements are basically the movements when they will be balanced. Do you say that this body will rotate now? No, never. These are two conditions. What I have told you, everything, I will just be finished by these two lines. Okay. So first condition, if the algebraic sum of all the forces acting on the body is zero, and second condition, if sum of clockwise movement is equal to sum of anti-clockwise movement, then body is at equilibrium. Right? Which is another very important topic. Actually, I told you this thing now, which is written in the red, the principle of movements. This second condition is actually called principle of movements. Okay, principle of movement says that you have to recall this also. So principle of movement says that sum of the clockwise movements is equals to sum of anti-clockwise movements if body is in equilibrium. That's it. It is the same thing what I told you here in the second condition. देखो, sum of clockwise movement if को हटा दो, right, then what will you say? Sum of clockwise movements is equals to sum of anti-clockwise movements. That is the second condition of equilibrium, and the same thing is being stated here, but this is used for calculations more frequently. It is used for calculations. Never forget this for calculations. आपकी most of the calculations देखो, until I mean up till this point, what I told you one formula. That was the formula of only moments. Now you have to use another one. Yeah. Mathematical form of that is this one. This is its mathematical form. Okay, mathematically you have to recall it again. It is a humble request to recall it. F1 d1 equals to F2 d2. This is the simplest equation, but it can be extended in case of two moments. This is only in case of two moments. In case of two moments, if there are two moments, this will happen. But now, let's say, let's go for two moments first. ना फिर तीसरे पे आते हैं. Check. There are two kids sitting on a seesaw. One is producing a weight of 450 Newton. Check this one out. This is the weight of 450 Newton. And the other kid is producing the moment, sorry, a force of 300 Newton. It is basically what? It is what? Force, not the moment. This guy is sitting at a distance of 1 meter from the pivot, and this is sitting at a distance of 1.5 meter from the pivot. From the pivot, kid is sitting closer to the pivot. So this will be F1. This will be your F1, and this will be your D1. This will be your F2, and this will be your D2. So when you are going to apply the principle of moment for these type of questions, you will simply write F1 D1 equals F2 D2. So what is F1? 450 times what is D1? It is 1. And what is F2? It is 300. And what is D2? 1.5. So the answer of left hand side is 450. Answer of right hand side is also 450. It means this is the boy is producing anti-clockwise movement and the girl is producing clockwise movement. So I can say that clockwise movement is equals to anti-clockwise movement, isn't it? Are you people? But the problem is when you are asked to calculate any unknown force. Let's see here. Here you are not given by this force. You are asked what will be F. Okay, so you will apply this formula to calculate. Check what is F1. F1 is 120. I'm going to apply calculations here. F1 is 120. What is D1? 6 meter distance from the pivot. F2 is F. I don't know about that. And D2 is H. Is it? So just apply this one. F1 D1 is equals to F2 D2. F2 D2. I'm saying that I have a task that if there is a force of 120 Newton downward at this edge of the rod, and there is a force F on this edge of the rod. I do not know about that how much force that is, but the distances are given. One distance is d1 and it is 6 meter, and the other distance is d2 and this is how much, it is 8 meter. Okay, this distance is your 8 meter. So I want to apply principle of movement, and I want to calculate F. Okay, my task is I have to apply sorry, my task is to calculate this force, that how much force do I need, and how I will calculate that. My procedure is I will apply the principle of moment. So remember one thing, that when we are having these forces, then we will apply the formula F1 D1 equals to F2 D2. Okay, and yes, F1 is 120 Newton and D1 is 6, F2 is unknown and D2 is 8. Just F2 will be 120 times 6 divided by 8. So what will be that? Solve here 90 Newton. I mean, this is the question. What I have put from the to explain to you. Don't worry. There is a lot of explanation in written format. I mean, in typed format. Then there is this question. So I believe that if you will be done by these all, इससे मुश्किल क्वेश्चन नहीं होंगे आपके पास. If there would be someone, I will help you out. Don't worry. Okay, look at this question. I will solve it for you. I will not follow that written stuff. Just let me copy this for you from here. Here is the diagram, and in that diagram, there are two ropes. The rope questions are actually hard one. That's why I have selected this one. Then I will select that pivot one. वो भी मैं समझाता हूँ आप लोगों को. In this type of question, one rope will be basically your pivot. One rope will be basically your pivot. And how will you find that is pivot? You must hunt a word about. बस अगर आपको about का word कहीं से मिल जाता है ना, that is your pivot. For example, if it is written about A, so it means A is pivot. This about A shows A is pivot. Okay, and if it is written about B, if it is written about B, then it means your B is pivot. Is this clear?
Yes, sir.
Okay, so I'm going to make A as a pivot in this question, and you are going to calculate simply, shortly. मैं direct यहाँ पे लेके आता हूँ. What will be the tension in this rope if this rod is in equilibrium? This is tension T, and you have to find that tension. Now apply some rules here. I will name these forces. For example, which force do you think that it will cause the moment here? This weight, we will convert it into force now. It is 2 kg, sorry, 20 kg. And if I convert it into weight, so it will be your 200 Newton approximately. And that is applied at which distance? 0.5. So just keep it as F1 and keep this as D1. 2 is 100 Newton. And what is D2 by the way?
1 meter.
1 meter.
Yes, well done. D2 is 1 meter. So this all is, you did all of that for your convenience. Now what you want, you need F3, right? This is, let's talk it or let's call it F3. This is your F3. You are striving for F3. And at what distance that is? What is the distance of F3 from here? Force is 200. Okay, and the distance from pivot is this much for that force. I mean, that force is acting at a distance 0.5 meter. This one, so that is your D1. What is that? That is your D1. Is this, if I cut this rope, that B, then that will this will rotate down in this direction. So this D2 is the distance from pivot to F 2. That is why I just marked it D2. F3 is that force. Let me make it blue for you. That is the force, blue one. And the distance from pivot to this blue force is this much. It is. So I just consider it that it is D3. So I have written this, or I have mentioned that here, that is your D3. D1 is the distance from pivot. I mentioned this, that this is my pivot. What is this? This is my pivot. Point A is my pivot. So अगर आप सिर्फ इतना ईमान ले आओ कि F1 D1 is the distance from pivot till the point where F1 is applied, and D2 is the distance from pivot to D2 F2 is applied. मैं erase कर दिया मैंने सारा कुछ. ये लो, check this one out and get it out. This is simply pivot. Where is F1? I mark this F1 here. Is F2 here? If I want to mark D's here, what will be D1? From pivot to F1. Actually, this is your D1, 0.5 meter. Okay. Now, if I want to find the distance from pivot to the pink force, what is, or how much is that? I have to draw that one. This is your D2. D2 is 1 meter. If you are considering 20 kg, so if you name it कि ये F1 है मेरा, so the distance till that force from the pivot will be considered as D1. You will multiply the force and its distance from pivot. That's it. That distance is taken from pivot. So any force will be multiplied by that distance which is from pivot to that point. That's it. Force will be multiplied by that distance which is from that force to the pivot only. Pivot और force के बीच का distance बस. और ये pivot और उसी force के बीच का distance होगा. आप ऐसा नहीं कर सकती हो कि 100 न्यूटन को 0.5 से मल्टीप्लाई कर लो. नेवर एवर. इस पे ईमान नहीं आपका हो सकता. बाकी चलो चीजें ऊपर नीचे कर सकते हो आप लोग, लेकिन आप 100 न्यूटन को 0.5 से मल्टीप्लाई नहीं कर सकते, बिकॉज 100 तक जो डिस्टेंस आ रहा है वो क्या है, 1 मीटर है, 0.5 मीटर, 1 मीटर. द नेक्स्ट स्टेप, बिकॉज आई हैव अ क्लास अहेड, तो हम लोग ऐसे करते हैं कि मैं जरा आप लोगों को एक जल्दी जल्दी एक ट्रिक बता देता हूँ, एंड दैट ट्रिक इज, दिस इज योर M1, moment number 1, because this is for F1 and D1. Okay, this is your moment number 2, is it? Moment number 2, and that is your moment number 3. Which two moments are of the same direction? You will simply add them. All the moments which are in the same direction, you will add them. So you will write M1 plus M2, that is equals to M3. Am I right? So इसको मैं कह रहा हूं कि these are basically sum of sorry, not sum, SUM, they are clockwise moments, equals to sum of anti-clockwise moments, because this is only one, तो इसलिए sum करने की जरूरत नहीं है, but you can sum if there are more than one. Now just solve it for that. 200 into 0.5, what will be solution? 100 plus 100 is equals to F3 times 2, and your F3 is basically 200 by 2, which is equals to 100 Newton. So that rope will apply how much force? Calculate this unknown force.